next version.
Has it not already? They have closures.
It hasn't made it in as the name monad, but I'm sure at some point somebody's going to do a
I mean,
monad.
Rust has like 3 different features that are all monads, and they don't use the word monad for any of them. So
That's true.
All right. So just so you know, we are now in full unsafe mode.
okay.
Okay? We
Well-
are streaming. We are live.
Well, I was making fun of Rust, so that's perfect.
We are unprotected. All right. So, first off, thanks everybody for coming. I want to give, again, a thank you to our host for the evening, Vivint, for providing us both a space to meet and the pizza. And thanks to Andrew for coming to present for us tonight. A little warm welcome. And then we'll give a bigger, like hot welcome in just a moment. And yeah, thanks to y'all for showing up. I am your host, AJ O'Neill, or your organizer rather. And yeah, just want to welcome you to Utah, may the world's most unsafe meetup. And with that, we turn it over to you, Andrew.
Hey everybody, my name is Andrew Gossage, and this is kind of a part 2. I presented a 5-minute talk a few months ago, and it took about an hour and a half to get through, and we didn't even finish all the material. So this is a follow-up to that. What we talked about was the idea of implementing your own web service rather than relying on an existing web server framework like Express or Hono built on Node or some other high-level language, why you might want to build that yourself. We'll go over a couple of the slides we did last time, and then something that we didn't get the chance to do last time is I actually have implemented a server in Zig, and I want to show some use cases for that. A little bit about myself. I work for a company called RightGrader. We build grading automation software. I am a full stack developer there. Okay. Let's just skip forward a little bit. So when people talk about high-level versus low-level languages, which first off, that's kind of a spectrum and is a little misleading. 30 years ago, or 40 years ago, C was considered a high-level rather than a low-level language. As time goes by, the goalpost keeps getting moved on what's high-level and what's low-level.
Zig is the world's first low-level language.
Not that long ago in history, Zig would have been considered extremely high-level. It's higher level than C in some ways, lower in others because you pass around your allocators. But
It doesn't treat you like a baby.
It doesn't treat you like a baby. As the terms stand now, some features that are generally associated with high-level versus low-level languages is high-level languages, generally speaking, have dynamic typing. You've got JavaScript, you've got Python, garbage collection. Again, both those languages feature garbage collection, which means no manual memory management.
They also feature a lot of garbage. So.
They do. And the garbage collection is not as reliable, this is a little side note, as you might think. For one thing, a lot of people don't know about interning strings, which is something that a lot of garbage collected languages will do, where they will store the string so that they can be reused later. However, languages like Python are not always good at uninterning them later. So in theory, if you've got a long-running Python program, the amount of memory it can take can scale to infinity, which is not always going to happen, but there are situations that are well documented where Python, due to string interning and some other things being managed poorly, has crashed due to running out of memory. That's not a problem that you're going to run into in Zig unless you do things very poorly and make bad decisions. High-level programming languages are often interpreted. That means rather than being compiled by machine code, they're run by something else that's compiled to machine code. that's not universally true. You've got languages like OCaml, which is a very high level language, but is in fact compiled most of the time. And then for low level languages, generally the advantages people look at is fast. That's really it. The fast memory controlled so that you can control your memory footprint. A lot of times you'll consider them as having static typing. Some low-level programming languages do not have that because typing is in fact an illusion that only exists at compile time.
God bless you.
But that is one of the features we generally associate with them.
How about control? More control.
More control, definitely. And so when you start to think about, say you're going to build a web service, you start to think about what kind of system you're going to use to build that, what kind of framework. What are some, as a little bit of discussion, what are some things that some of you have used and why would you choose them? Why did you choose them? Anybody have any web dev experience? Just me?
I've used PHP, Java Spring Boot, Express, JS. A lot of those were because that's what the company used.
That's a good reason because that's what's already being used. That's a really common reason.
I use Go because it is as close to perfect as you can get without having to be a superhuman to use it.
You know, Go is a weird example on these features I've got here because it's garbage collected, but it's compiled. It's often thrown into the low-level languages, but really has a lot of features more like a high-level language in a lot of ways.
It's like a mid-level language.
It is like a mid-level language.
Well, what would you put C# and Java? Because I put it in the same category.
I'd put C# and Java probably in the same, maybe a little. I'd probably put them higher on the spectrum than I would put Go because they encourage more abstraction than Go encourages. They also encourage more importing a million different packages than Go encourages.
My choice for frameworks or whatever, I like to just explore, and when I hear about new things, if I see some presentations or something that are like impressive, or just I like to experiment. So that's why I've chosen things like Elm or Elixir. And now I'm exploring. Well, I'm not a low-level person, but I'm just interested in Zig.
Awesome.
As far as your question regarding why I would choose what framework for that.
So, a lot of times that people choose something like Elixir, you've got Phoenix, right? Mm-hmm. And Phoenix just sets everything up for you. You've got most JavaScript frameworks essentially set up half the things for you, and you can get going super fast. But it's kind of an illusion that you can get going super fast because at the end of the day, you'll end up with these instances where it's fast at the beginning but slow later. So for instance, some frameworks like Ruby on Rails will pre-assume a database schema for you, which is really nice when you first turn it on. You click the init button, and then all of a sudden you have a working database with a working schema. But 3 months down the line, you have no idea how to add a column to your user table. So that's one of the problems, and that's where building something from scratch can really help. So we're actually going to close out of here and look at...
You're going to close them all.
No, I'm not actually.
Thank you.
So I created not really a framework, but kind of a template for having your own server. And it's really super simple to kind of go against the idea that writing a server in a low-level language is super complex and super slow. For reference, I wrote this whole server in about 3 days worth of time. And not every part of it is ultra optimized or the right way to do things. But I'll show you a little bit later. It does in fact work, and it works well. So this is the main file. You can see this is only 41 lines of code, a little less because there's a couple blank lines. Super small. And that just initializes the server. The server itself is bigger. And here's a route file. It's super simple. So here's an endpoint, right? This is an hxget endpoint. All it does is it fetches and renders a template. And then it returns that. And to register this endpoint, all we're doing is essentially adding it to an array. Very similar to what you have in a lot of other frameworks. Extremely simple, not very complex. Obviously, if you're going to do something more complex than just returning an HTMX endpoint, that will add some complexity like it would do in anything else. But you can see, if you compared this to... Wow, my screen's like freaking out. It duplicated that line for a second. You can see this endpoint isn't really that complicated. You can probably tell what's going on just by looking at it, right? We're creating a value that we're parsing a query param from out of, we're parsing query params from out of the request. We're checking if the value is nil. And then we're rendering a template, and then we're returning the template. So super simple, just like you would do in essentially any other language. A lot of times I think there's a tendency to feel like things are scary because they're written in a low-level language. But really, it's an illusion. Writing this same endpoint in something like Express or Hono would not be all that many fewer lines.
I'm kind of scared about the NeoVim on Windows.
This isn't Windows.
Oh, I thought you were on Windows.
No, this is Ubuntu.
Okay.
Just
All right.
because he was able to get the projector connected doesn't mean it's Windows.
Yeah, and then, so talking about use cases for this, you mentioned Towery earlier, right? And so I was curious to know how hard it would be to implement essentially my own Towery. And for anybody who doesn't know, Towery is an alternative to something like Electron, where it uses web technology to make a cross-platform application. But whereas Electron ships an entire browser, Towery just uses the native browser. For Unix-like operating systems, that native browser is generally GTK to WebKit, which is a fork of Apple's WebKit with a lot of functionality written in GTK, which is the GNOME toolkit, but it's used in more than just GNOME. It's used all over the place. You can get it on Mac, you can get it on FreeBSD, you can get it on everything. So I'll show it running real quick. Here you go. I converted the web server I wrote into a native, quote-unquote, application. To show that it's native, I'm going to run a shell command through it.
Code execution as a design.
It's fine, though, because it's not touching the internet. What do they call the elephant or the alphabet in Arkansas? The impossible dream. I'm not sure I get that joke. Okay. If nobody's ever tried the Linux fortune command, it is have mixed results, let's say. Okay.
It should say, to defend off all of California is trying to tax it.
Now, how hard was it, do you think, to implement my own equivalent of Towery? How long do you think it took me?
3
Any
days.
guesses?
Oh, are we doing prices right?
One
Yeah.
day.
1 day? 3 days?
2 days.
I don't want to take 2.
37 minutes.
It closer to that. So,
Well, but you gotta have all the hooks to be able to, escape hatch and local storage and file access.
see, so Towery and Electron both have these complicated piping structures where you can access the native code. But it turns out you actually don't need that because you can just because you're running a web server anyway, so you can just run fetch requests. And they run reasonably quickly because they don't have to go over the network. They just go to a port on your own computer.
Ooh.
So you don't actually need any of those things. You can just do fetch requests in JavaScript.
Then why do they do it that way?
You know, I'm sure they have an answer to that question, but I do not. I don't see a good reason to do it. In theory, you could gain some speed by having a custom protocol rather than HTTP, but HTTP over a local server is extremely fast. We're talking like no, it is.
He's looking at me like.
Yeah, I want to see what Niles has to say about this.
I mean,
Like, I know, because it's 0 milliseconds. There's no latency. There's just all that overhead of parsing the HTTP headers that translates into instructions that aren't even SIMD.
I know.
I mean,
It bothers me too. We're on the same wavelength. Should be AVX 512 optimized, in my opinion.
so I mean, we'll just look at this file though. This file is essentially all you need to get your own native rendering of JavaScript, HTML, and CSS. I normally don't recommend bringing in a bunch of external dependencies, but GTK is already installed on almost every Unix operating system. So it's already there. You can use it for free, and it'll essentially just work. I have tested this application on both multiple Linux distros and FreeBSD. So cross-platform for essentially free, right? Less than 50 lines of actual code. Did not take very long.
I wonder how many people are interested in web technologies for like screen readers and like accessibility technologies. Like
That's over there. That's the
I
next
just-
room,
I was
sorry.
just wondering, like, I mean, when it comes to Electron, it feels to me like that's really the main thing that you get. I would assume, but I don't know.
So web technologies definitely have a lot of built-in accessibility, and by just using web pages, you can just use a lot of that. So it would work with screen readers. It would work with any sort of thing where if you were going to do your own custom display, you would not get that. So that's one of the reasons to do it. Also, if you do want to bring in an external dependency, there's a lot of different things that already exist that you can tap into. One is HDMX, which is really good for this use case. Another thing is it makes updating super easy if you wanted to build in an update mechanism. If all you're doing is updating the front end, you can just make a web request to another server that serves that and then save those files locally to serve statically, rather than having to download a whole new binary, which is actually what Facebook does. So your Facebook app on your phone is running essentially a web view. And the way they handle updates is they just pull in new static files, more or less.
It's also a great way to push updates without having to go through App Store approval process.
Yep. Okay. So I wanted to show another use case and kind of the feasibility of using this server. Although I did want to show something funny because this can do arbitrary code execution. You can call a high-level programming language from a low-level one. Oh, I didn't implement the button click. There you go.
Wow.
Something that you could easily implement with something like this, I say easily as a relative term, you could build your own Insomnia or Postman. You could build the equivalent for using SQL and have kind of the advantages you get with HTML and CSS. So on feasibility, in order to assess the performance of this, which benchmarks are a soft science, to put it nicely. But I implemented an endpoint both in my own custom server and in Bun, which calls SQLite to read 2,000 rows of data from a database and then render it into an HTML template, which is exactly what Bun claims to be optimized for, and is. It's not just a claim, it's true. They have a very fast SQLite binding, and for being more or less single-threaded, they run extremely fast. So I wanted to see if, despite that, I could beat them.
Are you running single-threaded on yours?
I am not.
All those cores, you just dump.
In fact, we'll see how not single-threaded I'm running in a minute. But that's fine, though. The reason Bun is single-threaded is because they opted into JavaScript. If they didn't want to be single-threaded, they didn't need to use JavaScript. Which, to be fair, Bun is not entirely single-threaded. Parts of their process run multi-threaded. But your actual web request handling is going to be single-threaded in the event loop. So in terms of the end result of what I got is over 10,000 requests a second on my machine in my server, whereas Bun was able to crank out just under 3,000 before it gave up. Eventually Bun just stopped wanting to do anymore.
I've been there.
So here, as a disclosure, here's the hardware I ran this on. I ran this on my desktop at home, which has an AMD Ryzen 7 7800X 3D with 16 threads at 5.05 gigahertz. I don't know why I put the GPU on there. None of this used the GPU. About 62 gigabytes of RAM. I ran this on Omarchy, Linux, and there's more information that needs to be there. I don't know why that's there.
You put your shell type too. Amazing.
So this is where we started. So I wrote essentially the same code in Zig and Bun, as close as I could get it. And starting out, I started with about 1,000 requests per second, which was a third as fast as Bun, which is incredibly slow. The reason Bun is able to be faster is because they have handled a lot of SQLite optimizations in the backend. So the actual server speed for mine was, like the raw server speed, even at that point, was faster for the Zig server. But because of the SQLite requests, it became about a third as fast. But because we have a lot of control, we're using the actual just SQLite library rather than a binding written by somebody else. We're able to control a lot of the pragmas, how they're set up, and that increased our speed massively. And that led to...
Switch. What did you change with the pragma?
One of the things was wall mode, which you can turn on in Bun. That was turned on in Bun as well. There's a lot of things you can control the cache size. Another big change is we started using prepared statements, which isn't quite as easy in something like Bun, where you pre-compile. If you have a known request, you can pre-compile it, because SQLite uses essentially a virtual machine like Java. So a lot of times in JavaScript, you're just going to be compiling that at the time, which there's ways around. But in Zig, that's super easy to control what's compiled ahead of time and what's run as needed. So using prepared statements increased the speed by a whole ton. And then a big increase, which is something you cannot do in Bun, is using thread local storage. So in Zig, you can have multi-threaded operations. And in fact, for most of these tests, I ran my server with over 1,000 threads. Because the threads are reasonably lightweight on a modern operating system, a modern computer with any decent performance, you can realistically run one thread per request if needed. Which is not something you can do for Bun, just period. You can use load balancers, but you're going to cap out your CPU really fast because every thread that you run on Bun is going to be an entire instance of most of a web browser running. Yeah, so again, wall mode, prepared statements, also did transaction batching for the inserts, but that really wasn't a big part of the speed because the inserts only had to happen once. Thread local storage, because Zig can run multi-threaded, but you do not have to share variables and have mutexes for anything that does not need to be shared. So by removing mutexes and locks and keeping memory that can be limited to a single thread, limited to that thread, you can increase the speed drastically.
How would you do that in SQLite where you have, are you saying like any thread that accesses this table is just this thread or something like that?
So,
how do you partition it?
So SQLite has to be essentially single-threaded for writes, but if you're in a read-heavy operation, you can run it multi-threaded, as many threads as you want. So some of that data can be unique per thread and can be cached.
So this is a read-only instance, is what
This is read-only, yes. Some of that you could still do multi-threaded, so there are ways to handle. So wall mode specifically is designed at, wall stands for write ahead log, and that is a built-in mechanism to handle multi-threading in SQLite. And it does offer some benefits to reads, but if you are doing writes, it's essentially mandatory to do multi-threaded. But you can do multi-threaded SQLite.
Well, and you could do like there's no reason that all of the things become background tasks that go into worker queue, so JavaScript should use multi-threaded reads as well.
JavaScript can use multi-threaded reads to an extent. The way that it mostly works is so when the requests are coming in, you can multi-thread that. When the requests actually get to the runtime, they're put into a single thread.
Yeah.
And so that's always going to be a bottleneck. When you do an async await, those typically go to a single other thread to be processed. So you've got two threads at that point mostly, and then those can be dispatched out to other threads at that point to a limited degree.
And I guess in JavaScript, your JSON parse on your single thread is probably taking more time than your embedded SQLite.
Yeah.
we're working on that.
SIMD.
Yeah.
SIMD JSON.
Zom
So-
Magic Powers.
As kind of an end result of the optimization was we're able to handle over 10,000 requests a second, which would be over 600,000 requests a minute, over 36 million requests per hour, 880 million requests per day, and 400 megabytes per second sustained throughput. Again, so this was a read-heavy operation, but it pushed all that data out uncompressed. So Zig was able to handle that like a champ, all on one machine. And let's see if I actually... No, I had on here when Bun quit out, but I guess I removed it. So Bun... Oh, here it is. So Bun quit out when I tried to push it to serve over 3,000 requests per second eventually, concurrently. So after I pushed the concurrency of the test to over 1,000, it just stopped working, more or less. It just refused to even try and queue them. Whereas Zig is able to handle that on a single machine. And if you did run into limits on the machine, you could still scale it to multiple machines the same way you would with Bun. And the actual test here, like I said, benchmarks are a soft science. Here's a stress test I ran where I ran 100,000 requests in a row with a concurrency of 1,000, and it performed pretty decently, I would say. But these are a soft science, and the specific optimizations are not really what is important. What is important is that by building something yourself, you can decide where you're going to optimize. So again, like I said earlier, Bun has a really optimized SQLite binding library built in. But they optimized it for the use cases that they thought were going to come up. And they may be right most of the time, but they're never going to be 100% right about your application. You are always going to be faster writing your own solution than using somebody else's solution if you do it right. And so kind of the point of my talk is I am not a miraculous, wonderful programmer better than everybody else. I'm quite a normal programmer. And if I was able to scale something up to be able to hand millions of requests easily in this only took like an hour. Somebody who actually knew what they were doing, like Niles, could take this so much further. There's so many parts of this server that are not optimized. It's not that hard to build yourself, and there's a lot of advantages you get. And then just because I think we do have to talk about another issue real quick for using something like Bun or Node or Dino to a lesser extent. So I'm going to go create a new folder. I'll make this bigger. Okay, I'm just going to init a new project.
Look at those emojis.
Yeah, got that nerd font installed. Well, I'm running Ghosty. Now I'm going to do Bun add express. 68 packages. My server that I wrote has 0 external dependencies. I added SQLite and I added GTK for this specific example, but that's not the server itself. If you write something yourself, you can have 0 external dependencies. 68 is already such a high number that you're never going to be able to audit every package in there. If you install anything else, I have done installs where you add one package and it has literal hundreds
Thousands.
of transient dependencies.
They fixed React, never mind.
They just broke it into smaller pieces.
So
They made it so that when you install it, it only is like 100 dependencies.
So
I'm not gonna
one
give a standing ovation for that, but you know.
one thing that people push with using existing solutions is security. But at the end of the day, these existing solutions may be secure and they may not be. It's very difficult for you to audit them. If you write them yourself, you've written them, and if you don't know what you're doing, maybe you do it wrong, but you can at least audit it to know what it's doing.
One thing I wish that they would do with this, because I think it's more important than the number of packages installed, is the number of authors. Because that's where the security problems have been happening. Like, how many times this month did NPM have like some major
3 or 4
author get their credentials hacked? So that's the big thing. But I do want to say to express this credit. After 10 years, they finally released the new version. It was literally over 10 years. And there's a lot of stuff in there that's a pain in the butt to do yourself, like e-tags, MIME types. I mean, like all of it you can do. And some of it you think like, oh, this is just a 15-minute job. Like how long does it take to match a MIME type and then, match a file extension and then map the correct MIME type? And it seems like it's a 15-minute job, but then after a day, now you have your MIME type package.
So MIME types specifically, though, if you are going to use a reverse proxy, which if you are using Bun or Node, you're going to be doing anyway. And if you're doing a Zig custom server, you can. The reverse proxy is able to tag MIME types effectively. That is a feature built into reverse proxies if you don't want to handle that part of it yourself. And then you're only offloading that part of it.
Yeah, but I mean, you're only offloading that part if you pull in the dependency, right? I mean, the dependency for that. Anyway, I'm just like, I agree with you. You know I agree with you. But I just do want to point out that there are some realistic trade-offs and like some things, I mean, it's so simple. It's like how, I'm just going to copy and paste this code. It's going to be fine. But then it does take longer than you think.
Yeah. There are definitely trade-offs. My point, though, is if I can do it, you can do it, and it's not that hard. And there are tangible results where you can serve more customers, you can serve faster, smaller bundle
better
sizes.
Knowledge sharing your organization.
You can, and if something breaks, you can know where to go to fix it.
Yeah.
And that's all I wanted to go over.
All right, well, thank you very much for that 5 minutes. It was quite enlightening. I feel like I got so much more. All right, so now is the time where we can ask some questions that are on topic. And then the questions that are off topic afterwards.
What version of Zig do you use?
15.
Um,
The server was originally written, I think, in Zig 11, but I migrated it
yeah,
up.
because they wrote how we did the server version.
I actually wrote this server initially before Zig wrote its standard HTTP server library. So originally this was a full server just on top of TCP, but I stripped those parts out when they weren't needed anymore.
Is this still Zoe?
It is.
Okay. Making sure I put that in there.
Do you like unwrapping optionals with the if syntax?
No.
No. I saw in your code that you don't, so I was just wondering.
Oh, you even got a website for it, like a domain.
Yeah.
And where, can you give me the link to the presentation? Like just click the share link for me so I can throw it in the video.
Like these slides.
Yeah.
Um.
And then your desktop browser, wait, what are we calling it? The wrapper, the web view. Was your Zig web view also in this code, or was that?
It's actually in a different repo, but it is public. It's called Thanatos.
What does that mean? Is it okay
So-
to say that on stream?
Yeah. So Zoe is the Greek word for life, and Thanatos is the Greek word for death.
And, oh, yeah, I'm not. This is an unsafe meetup, thankfully.
Um,
In the top right hand side.
oh yeah.
Oh, you do not have a description for this in your about page, just so you know. Oh, and it says Zoe at the top.
What
I
does?
think your Thanatos, the README says Zoe.
Yeah, I haven't updated the README.
Okay.
It did not show the copy link, but I can throw it up.
Well, what's the correct term for this? A
There we
WebView
go.
wrapper?
Yeah, that is the closest thing to it. Okay, there's the link in the bar to see the slides.
Okay, I'm gonna make it work somehow.
And then,
Do we have any questions in the online chat? I don't think anybody's watching online.
why did they add an Ask Copilot to the homepage of my... So here's the repo for the version with the web view built in.
I know I'm asking a lot. Will you open an issue and paste the link in the issue and I'll just copy it from the issue?
Yeah.
Can you do it that way? I do wanna, someday, I wanna look into this, hopefully before the iOS system gets rewritten again.
There isn't really that much in the slides. The slides are from last presentation, but
That's okay. What
most
about-
of the presentation was embedded in the web view itself.
Yeah. That was very good looking though, by the way.
Thank you.
Okay, any other questions?
In your like spreadsheet of the benchmark steps that you took, were those additive performance increases, like 50% faster with this and last one thing, or like
That was,
individually?
you know, I don't even remember. Let me look. Did I close it? No, I didn't. It's still
Does
open.
Windows have memory mapped files? I've never heard of that term before.
I think it does. Could be wrong. I don't know.
Yeah.
The number for prepared statements, is that prepared statements and SQLite, or just prepared statements?
So this is the improvement from just this step. So just adding this made it 244% faster than it was from the previous round of improvements. Okay, any other questions?
So Bun kind of naturally facilitates more of a read-write arena because it's single thread, right?
Yeah. So you can do multi-threaded SQLite as of the last few years, but the problem with that is you have to know what you're doing, and not everybody does, and it's not obvious that you need to do some of the things you need to do. Once you know to do them, they're not hard to do. They're super easy, but people haven't been taught to do them, and you're not going to run into a lot of the problems that you will with multi-threaded when you're just using Bun. In Bun, you don't have to change those settings. It will just work most of the time. Until you try using microservices. And then you need to know to make those changes.
So what are those things that you know to change?
I mean, I mentioned it a few times, but wall mode is the number one. They're changing your cache sizes, all sorts of different settings can affect performance.
The cache size.
The cache size, I don't remember.
Well, I just wonder, like, it'd be crazy to me if it wasn't 64, right?
Yeah, I don't know what it is by default. I know that tuning it can give you better results. Sometimes making it too big can give you worse results, though. So there's some tuning, because if it gets too big, then when you have to do a flush, it can be slow. So there's some fine tuning you have to do, but wall mode is the number one thing, which you can do in single threaded code. It's super easy. It's one line of code to set things to wall mode, but most people don't do it. And then it works until you add a microservice, and then it breaks and your database gets corrupted.
Wait, what are you saying about microservices? You saying what?
So running a microservice is, in terms of its impact to the database, going to be more or less the same as running multi-threaded requests on your SQLite database. And so having the write-ahead log mode is necessary because that is how SQLite handles multi-threaded applications. If you are running microservices and you don't have some kind of external mutex, which is possible, some people do that, but that's a weird thing to do.
I'm misunderstanding something fundamentally. What do you mean by microservice?
A microservice architecture, like you have multiple mini applications operating on the same database.
Oh, so you're saying they're opening it from the file system.
Correct. That's how you handle that in
Is that a
SQLite.
supported use case for SQLite?
It is when you've got wall mode. It's just the same. The settings you use for that are the same setting. Well, some of the same settings I used for making this multi-threaded friendly on Zig.
Did you do anything else important besides wall mode and the cache line size?
Yeah, there's quite a few things that are small tweaks. They're all in the code. I don't know that any of them are interesting in and of themselves. Wall mode is extremely important, though.
Did you do anything interesting in the way of like a mutex, any kind of like structure or wrapper for?
So I tried different strategies for mutexes and locks, and honestly, and there is some of that in there, but anything that does not have to be mutexed using thread local variables is much faster.
Yeah, it's more of a you use it when you need it sort of thing.
You use it when you need it, and you avoid it when you don't need it. It is so. I don't think I called it out, but just moving the mutexes, just removing them, led to making it multiple times faster when I turned those off. And then, yeah, mutexes are slow. Well, the actual mutex operations aren't slow, but having mutexes is slow.
Have you ever read the PostgreSQL article? You get it 1,000,000 times slower.
Yes. I have.
I do like that
47,000 times?
Million.
So Postgres is an interesting application. I don't think so. Postgres has become the popular thing to go to, and I think SQLite. I'm a little bit of a fanboy of SQLite. In read-heavy applications, SQLite is faster than Postgres, and
Whoa. Oh, the screen is going dark. I thought there was a website for a second. I'm like, death is coming over.
even in applications that rely on a lot of writes, there's a lot of code in Postgres that is designed to handle things that you aren't going to be doing most of the time, and that will make it slower by definition. And so if you don't need to have massive scaling and all these insane JSON functions, I don't know that Postgres is the right thing to go with anyway. But it is funny that you can make it slow.
Maybe as a joke, you could also say we make our web server slower than Bun.
We did initially make our web server slower than Bun, that is true.
Well, I mean, anything that has, so SQLite is embedded, meaning that it's in application. So, I mean, one thing you're doing is you're reducing the latency of those HTTP requests, which in the case of SQLite has a specific advantage, whereas in the case of a web view, probably does not have a specific measurable advantage. Measurable but not impactful, rather. So like anytime you know, somebody says, oh, well, this big, huge program that's, you know, services, enterprises can be beat out by this thing I wrote in a weekend. Well, that's actually not surprising because the thing you wrote in a weekend handles exactly the use case that you need and not
But-
all the ones
but
you don't.
That's my point. You don't need all the. So these applications, it's not that they're bad. It's that most of the time,
They're generalist.
yeah, most of the time you don't need an eighth of the thing they do.
Agreed. All right, well, it seems like we are venturing into other topics now, so one more round of applause. And I would appreciate it if you could frown a little more while people are applauding. That would be preferred, because you only kind of slightly tilted down, and I wanted a full, like, basset hound, you know? Okay, and with that, we'll end the stream.